Okay, today I want to make the distinction. I want to clarify the distinction between a solid state drive, okay, and a, a conventional spinning drive. Spinning meaning means it spins, it goes around. Okay, there is a platter here. There is a plate, like a plate, okay, metallic plate which spins here. So this is a 2.5-inch hard drive, a conventional hard drive, a mechanical hard drive. Mechanical because it has mechanical parts. It moves around. There is an arm here with a and then a platter, and then the spindle and everything. Like, okay, not like in a CD player or a DVD player, but at least it has somehow in the same way. It has a what? It has a motherboard here, which is a circuit, a motherboard which is a circuit, okay, a circuit which controls the electronics into the transferring and data and managing power and stuff like that. So now this one is the conventional hard drive for the laptop. For the laptop, this is a 24 I mean a 20 I mean sorry a 2.5-inch hard drive, okay. So you see the stone, I mean the perforation here. You do not have to touch here, because if you touch here, okay, you are going to interfere with with the spindle, which is moving from one corner, okay, I don't know where the corner is, which will be moving on the platter. Okay, the platter is right here, so it is moving. So and if you touch here, you might interfere with the spindle, which is moving from this corner and reading, transferring, or writing data onto this hard drive. Okay, that is one. So this is a spinning hard drive, the 2.5 inches. Okay, here is a magnet. You can look for, you can search in Google or YouTube inside of a hard drive, and you'll see how it works. There are many people who have opened the spoiled ones, broken ones, and stuff like that. Some of the enthusiasts sometimes they go a long way even to buying new ones and opening them. Okay, if you open it once, it will never work again. Please, it's not to be opened. This is very fragile. If it hits, it is very fragile against shock. If it shocks, if it falls on the floor, on the ground, or whatever, it is dead. So it is very fragile. This is 0.5 inches. Likewise, there is this one. Okay, this one is a hard drive. This is 3.5 inches. It is big. Okay, it is big, but because these ones are working from outside, so this is 1 and 2. It is mounted in a bracket like this. You can see the relative size of it. This is 3.5 inches, so it fits in here. Each manufacturer is different. Okay, we'll put the bracket here on the case. Some of the manufacturer will integrate it on the case. Some will not need it, but you just bolt. Okay, you just screw the hard drive inside the case. I mean, on the case. Okay, it is designed in different ways. So these are pinholes, not pinholes, screw holes. These are screw holes here on the front, and in the back on the other side the same thing, which you will have to spin on a bracket or directly on the laptop or something like that. So this is the old model, the old style, but it is cheaper. It is cheaper. However, it is slow, a lot slower. If you use this once, you will be surprised. So you can use this to run Windows, to run the programs controlling the computer and stuff, and then use this one as a storage device. Now, you see the interfaces. This one can pin in the laptop. It can pin in the in the big computer as well, the desktop. So it is the same interface, the SATA interface. Here, the same interface. It has two cables, this one for power and this one for data. Sometimes the power comes from the power supply direct or from the motherboard, and this one strictly comes from the motherboard. Each two SATA cable mostly controls two hard drives. Okay, so you'll see how it is controlled. Let me show you. This is how it is. So this is the power cable. This is the power cable, and the yellow one is under here. You see there is 1, 2, so it is controlling 2. Okay, this one has come from the motherboard. This is an example from the motherboard. So it has two hard drives, and this is for redundancy. So this is all redundancy. Okay, now let's go back to the hard drive. So that is the big hard drive. Is mounted in a bracket like this. Okay, like this one, which we have seen. This is for Dell Optiplex 9010, 7010, 3010, and many others. Not all Dell, but some of them, some of the models I have described. So this is the mechanical hard drive. Why is it called mechanical? Because it spins, because it has mechanical parts. The spindle, the everything that I have talked about, and many others. You can Google or you can search on YouTube and see inside, looking inside of the hard drive, you will see how it looks like. Never open it, never shock it. This is very fragile. It is cheap, it is reliable, but the problem is shocking. So this is a solid state drive. It has the same interface, SATA, serial what? You can look for where SATA, you can search what SATA means, okay, but you have to know that is the SATA interface and SATA protocol, which transfers 400 and about 450 megabytes per second. Okay, so this one is the same interface and the same protocol. Okay, same interface, same protocol. This is a hard drive, but this is a box just to fit where this one fits. This is a box just to fit where this one fits. Inside this, there is this one here. You can see it has the same teeth, the same kind of teeth, which means I have removed it out. Okay, and if you want to avoid overheating, okay, to get a more aeration, okay, to have more air circulation, you can even remove it from here and mount it into the laptop when it is like this. It is so easy. It is so here air can separate, circulate on the controller, on the chips, memory chips, and stuff, and so on. Okay, so it helps it. Though this one is metallic, some are plastic. So metallic, there is an advantage with metal because metal conducts heat way much better, and plastic almost none. So the heat which is generated from the here, from the controller and stuff like that, can easily dissipate, easily dissipate through the metal. So, but if the casing is plastic, then you stand a chance of not transferring heat as much efficiently as you should. So these are the chips. These are chips, the power controller, the memory chips, and on the side, depending, because now you'll find a hard drive, a solid state drive, this one having 8 terabytes. 8 terabytes. Okay, each GB, 1 GB is 1,000 megabytes, and 1 terabyte is 1,000 GB. So some solid state drives have 8 terabytes, and it is very expensive. Okay, now this is for the laptop. This can go in the laptop, and this one you can mount it in the big computer, for a big computer, the desktop. First of all, it is very light, so you do not have to attach it anywhere. To tie it somewhere if you don't want, or you can get a thread and tie it, hang it up in the wall. But it is not. It is light, so it is easy to plug it in, and it dangles. It doesn't matter because it's light, but this one is heavy. This one is a little bit lighter, much lighter, just because of the case. Okay, and this one. So this is SATA interface. So they work together. They can work, but this is fast. This is fast. If you use this one, the solid state, you will never go back to this. Except now, because of its expense, of being too expensive, you can use this to run Windows, to have Windows or operating system and stuff like that, so that you use the rest of this for storage. Okay, this and that. So the big hard drive has the same interface as I have shown. Okay, the SATA interface, the same connection, the same size. So where this one goes, okay, in terms of connection, not the bracket. You can see this bracket is big. Okay, is more than 2 type. 2 is the size of like 2. It is really big. 2 or maybe how many? 4 or 5. that can fit in to fill in here. It can be more than 5 or more than 6. Okay, 2 times 2, 2 times 3 on this side, and 2 times 3 on this side. So this hard drive is big. Okay, but the good thing is this one is faster than the laptop one. This is 7200 revolutions per minute, and this is 5400 revolutions per minute. Remember, 5400 revolutions per minute, RPM, 5400 RPM, and this is 7200 RPM. So it is one half faster than this. This one is because it is a solid state, there are no mechanical parts. Okay, it is a flash memory, just like a flash drive. It is really fast in comparison with that. And then there is an NVMe. And in NVMe, this is 22 by 30, meaning 2230, meaning 22 inch, 22 in length, in width. Okay, 22 centimeters in width, and 30 in length. So it goes up to 110. 110, yes. 110, 110. So it can be long from here and here. So it will be marked 2230, 2260, 2280, and 22110. So it can be long. So depending on your motherboard, you'll see how it does what, how long it is. So this one is also solid state. It has the same chip memories, the same flash memories, flash chips. I mean, flash chips, just like they are on this one here, just like they are on this one here. So that's how this is made. But it has one different interface. This interface, the face is different, so it cannot fit in each other. The face is different, that is one. Two, the protocol is different. These ones have reached a point where they can transfer 7,000 megabytes per second. This is 500, which means 10 times plus faster. But that is theoretically. Practically, it is a different story. So this one can be maybe 1,000 or so. So, but it is fast. It is fast, and it creates heat. Everything has its ups and downs, the pros and cons. So this one, this is the solid state drive, NVMe style, non-volatile, which means it keeps it. It does not disappear. Non-volatile memory express, non-volatile. So this is not like a RAM like this one, which is on the motherboard here. Okay, this one, the RAM. Okay, RAM, which is mounted on this one, it keeps the memory while you're working on it. Once you have finished working on it, so I'm not going to interfere with this, but you know what I'm talking about. Okay, it will disappear. So it has also the chips, but this is volatile memory express, let's say, because of RAM. And I mean, that's how it is designed. You use it once, you turn on for the computer, it goes away. Whatever you have been dealing with goes away, and you'll have to start all over. But this one is non-volatile. That's why they call it non-volatile memory, because it does not disappear when you turn off the power. So that is NVMe. There is also which M.2 is called M.2 interface, but NVMe protocol. Now there is also the SATA protocol, the M.2, but using the SATA protocol, the same speed. So the teeth will not match. It is the same size, but this teeth, instead of being here, it will have two, meaning it can work where this one goes, but it has the same speed like this one. It is also faster, like this one is the same thing, but it is faster, much faster. If you use flash memory, I don't know, you will never go back. So that is basically that is it for the solid state drive and hard drive. I think I have explained it so well that you will not need again another explanation. I cannot make it more better than I have done today. So it can be very confusing, but you have to learn. You have to listen to the video read it, I mean, over and over and over and over. So it will be, I mean, you memorize, you cannot learn only once. These things cannot be only learned, cannot be learned once. But this is a comprehensive video, I think, about the volatile memory, I mean, the solid state drives and hard drives. So it can be mounted inside the case or in the computer. It can be mounted in a bracket. Mostly this one, even this one, there can be a bracket where you can use it with a USB-C cable. Okay, there are many types of brackets. Even this one, you can use it outside the case, and you mount it in a bracket. Okay, in a bracket, in an adapter, which will turn it into USB. This one, the same thing, because they are the same. So it will turn it into a USB cable. Okay, now like this one, for example, here, watch, see this. This is a hard drive. Okay, it is mounted in. It is mounted in a bracket. You see the bracket? Okay, so this is plugged in here. It is plugged in here, where now you can be able to take a USB-C cable and plug it into the, this is a motherboard outside, but it is always inside the case. So this is USB-A. So this one has most of the computers, they have 6 USBs, different versions. That's also another course. Okay, so this is USB. You are using it as, you can run it on Windows. You can run Windows on it while it is outside. This one I have opened. You close it. It can close. It has the top cover with the motherboard, the controller and stuff, which converts it into a USB interface. Okay, so that you can use it. So that hard drive, you have seen it. You can Google how what a hard drive looks like if you've never seen it, and you compare it. Here you can use these pictures to see the difference, or assess or gauge the size depending on the scale here, how it looks like. You see, it has taken the scale, the size, the length of 2 hard drives, so it can tell you how big it is, what the size is on in terms of scale. Okay, so that is it now. Okay, this is a computer. It is built outside. You see the fan has stopped. I will go into this later, but this is a complete computer. You have been hearing it. Roaring. Okay, you have been hearing it roaring. The cable, the fan is there, is running, is mounted. You can mount it on the board direct. Okay, using its connectors. Okay, you can run it outside, or you can use a USB to run it. So this is an open computer. So that is a graphics card. You do not have to have a graphics card always, okay, because it has connectors. But if you want a clear picture, or to play more heavy videos or games, or processing some material like videos and stuff like that, then you will need to use a graphics card. We'll not go into that. So this one, you can take it out. It has a button. Again, the button is underneath. It's here. You push. This one is made for pushing down. So you push it down, then it will release. It will somehow push it up. You can see how it is designed by use of the camera. That is a good thing with camera. Okay, this is underneath, because I have inverted the camera. So it releases. Once you push it up, push it down, it will lift it up, and then you can take it out. Here, this whatever here, this clip here helps it to get locked onto the motherboard, because this one is fragile. You can easily, it is soft, I mean, you can easily break it off. Okay, this is a low-end motherboard of the series of a 9010 series, 9010, 7010, and this is 3010. So it has fewer connections, or it is somehow inferior. It has even fewer SATA connectors and stuff like this, that, and in fact the chipset also could be different. So with the chipset, which allows how many how many things you can connect and stuff like that, and many other things. So this is the lower end. That's why I'm loading it. I have loaded it with 2 hard drives, 18 terabytes and stuff like that each, okay, and using the power from the motherboard, so that I find out how much it can load. Can it really load? But it is satisfying, okay? It is satisfying. It has done it so perfectly. So that is a computer. Simply you plug it in, you click it in. Everything that you pull out here, okay, like this hard drive, for example, like that hard drive, it has a clip which you press, you cord together with this and pull it out, meaning you have to take this one out, so that this clip you have to press it and push it down a little bit so that you can take it out. The same thing with this one here. Okay, it has a clip on the motherboard power, the power whatever for the hard drive, the power connector, everything here. You have to press a clip like this so that you pull it out. And even the power the power line, it has a clip. Okay, you can see it. You can see the clip here. It is black. Okay, and pull it out. We'll go into that, but today was about hard drive. So you please use a clip to push it down. Okay, you push it down before you, so that the clip can get out of it, get out of its neck, and then pull it out. So this is a plastic can, a plastic whatever can, which I have cut. And you see, you have to be creative. And now it is holding hard drives. You see, it is successfully holding hard drive. Let me take these ones out. This one, if you want to know about it, you can go back into the video. You can go back into the video. So let me put it out so that you can see. So this is the power supply. That is the power supply. Okay, it has a fan. It has to take air from here and expel it from the other side. Okay, that is from the case. This will be in the case, or something like that. It will take it from one direction and take it out. So this is most likely outside of the case, whatever, but you have to follow how it works. So because it generates heat. So these are hard drives. Okay, you have seen how I have mounted it. I've cut it and it is comfortably sitting. Cutting it, and here it place papers so that it can separate and gently separate, so that air can pass through. And this is not hard. It has to be soft enough, so that, because why? It has to be soft so that it does not press on the side of the hard drive. So it has to be shock absorbent, like a rubber kind of, so that it does not create a shock in the hard drive. Okay, so this is the motherboard and the fan here. You can use a USB fan. This one is not mounted permanently. Like you can see, there's a lot of wire redundancy. I have put in the connectors, the adapters, the connectors to lengthen the wire. So they are wire. This is 24-pin power connector, and because this motherboard uses only 8, so I have put an adapter here. An adapter here, so that it can turn it into eight wires, for this motherboard, because each motherboard is different, but the standard ones is 24-pin. Like this one is not standard, is not 24-pin, so you have to buy an adapter if you are using a standard power supply of 24-pin. Okay, 24-pin is the best power supply to buy, because you can get an adapter and use it on any computer. Okay, 24 pins, please, is what you should buy. If you find a computer and it does not have the 24 pin, you should be careful, because do you think you can use it? It is hard to upgrade it, or to modify. It is expensive. It is more expensive, because you have to spend more money. Into it. For example, this one, it has fewer PCIe Express connections, where you can put another card, a controller card, which have SATA. Some SATA whatever connectors have even 5, 4, 5, 6, 10 SATA connectors, whereby you can add more SATA hard drives like this one. even some have 10. So you plug it in here and you put in 10 hard drives in the same thing. Okay, but if it is short like this one, it is short, is only by one because it is a lower end. If it is more expensive board, more higher end, these ones will belong maybe like 16, because it is either it is 16, 8, 4, and 1. But this is 16, 1, 1, 1. Okay, so they will belong even if it is one, but by one protocol, one lane. Okay, it will be longer. So you'll find 16, 8, 4, and 1. So you have many options to upgrade, to expand. But also, what controls is the chipset. The chipset is very, very important in controlling how many things you can add on this. So that's why you had, when you had a connector, the PCI Express connector, which or the card, it has a controller which controls hard drives, so you can add it on even if the chipset does not originally allow these more hard drives, these many hard drives and stuff. And also you can add here and add another card. You can add and maybe add USB-C, you add USB, add the echo. There are so many things. That's why they are called PCIe, peripheral express, peripheral external, whatever. You can look for it. Peripheral component expansion express. Interconnection, peripheral component interconnection express, which means you can add anything. You can add hard drives, you can add USBs, you can add a sound card, you can add many things. You can add just like USB, because USB now you can use USB to add a phone. You can use the same USB to add a keyboard. The keyboard is here. Okay, it is under. You can the same USB you are using. Mouse is where? Where's the mouse? Okay, mouse is here. Mouse, please, again, use the mouse. Use the mouse instead of using the touchpad if you're using a laptop. One, it is cheaper. That is one. Two, it is easy to learn, and it is direct. It is very easy to learn. You press and hold and pull and what and select and stuff. It makes it easier to learn than a laptop. Okay, and use the physical keyboard. You should use a physical keyboard, even if it is wireless or wired using USB, because I think in the future we shall not be, the keyboards and mouse will not be wired. They will be wireless, because wire costs money, and so you will. But in the future they will be they are becoming cheaper and cheaper and cheaper. So that is the mouse. The left click, left click, right click, right click, left click, and scroll up, down, press and hold and pull. That's when you are selecting many other items, when you are looking and stuff like that. So that computer is connected. Okay, the fan is running, has not been running, because when it takes some time without working, it goes into hibernation mode. So but it is functioning in the background. So it kind of turns itself off to preserve power and stuff like that, but it is not actively working. It's not actively working. So you can see it is working. 1, 2. So that is it about this thing. That is it about this thing today. Okay, so the graphics card, this is not connecting the screen. The screen is connected directly by this wire. By this wire is a DP. You can read DP. Okay, it is written DP, so it is a display port. It has one display port connector into the screen, and you have to tell the screen that you turn it, like for example here, menu, you go to menu button. You go to menu button. Okay, it is here. You look for where it is, and then press it again. Yeah, press it again. Then it will bring that HDMI 1, HDMI 2, so, and stuff like that. You press it again, input, and if you look for the menu, you go to input. What are you inputting? So HDMI 1, because it has HDMI 2s. It has HDMI 2s. So, okay, it has two of them. So in the back, So this, whatever this fan touched on the cable. So you see, now it is showing you no signal because I took it from HDMI 1, yet it is on HDMI 1. Yet it is on HDMI 1. So it shows you that no signal, yet the signal is there. So now you have to wait for it, and it is retrieving. So it will show you that, I mean, it will connect, you see? It is connecting. But if you use the different, I mean, the wrong, the wrong whatever instructions, then, or the wrong hole, the wrong inlet, wrong port, it will, that's what it will happen. You have been seeing, it is showing you no signal, meaning signal from the the picture is not coming from from the computer. So this is a complete computer. You can see it has everything except this is a test bench, a test table. Some people call it bench. It is a test table to test everything. It's not big. It's not big, but you can see. So everything is just plugged in. Where it does not belong, if it is not SATA, it will not enter here. If it is SATA power, if it is not, it will not enter here. Everything is made to fit where it belongs. That is it. There's no shortcut. There's no nothing. Okay. There's a lot of redundancy here. I have put the wires here. Redundancy for hard drives. Okay. There are many. There are many. I have bought connectors and added them up and expanded them. There are others where you can use the headers, different headers, and you use it. Okay. So that is it. That is it for today. I think we should stop this video here. It's not has been about hard drive, but at least we have gone onto the motherboard to see how it is. So what you connect on the motherboard is power connector, 24 pin or 8 pin or 6 pin or even 4 pins. Okay. That is the power, the main power. 24, 8, 6. So they are different. Each motherboard, each make is different, but the standard one is 24. Always try to look for 24. You open the laptop, the motherboard. Okay, it has just a door which you just clip out like you're opening the whatever door, the house door. Okay, and it gets out. So you see, it has 24. That is the best computer you should buy. Okay, you can buy, but depending, or if you have expectations in the future, don't. It's not. Then again, it has the primary one. It has 4. It has 4 power connectors, 4 pin power connector for the CPU. Okay, you can see 2 yellows and 2 blacks. So that is 4. That is 24. This one is 6. I mean 8. This one is 8 plus 4 for the motherboard. If one of them is not there, it will not work. And once these fans run like this, it means it is working perfectly. So you have to deal with the drive. If it shows up and it starts as a bot, it means you are okay. If the screen shows up, it means you have only one problem or one issue to solve, that is putting in a drive with Windows. Okay, which if the RAM is not there, if RAM is broken or what, then you have to take you have to take them out and insert it one by one at a time, so that it boots up. When the fans are running, okay, which means everything is fine and the RAM is okay, the CPU is okay when the fan is running. If you don't have fan and you're just testing, then you can alternatively put grease like I showed you here previously in one video. The thermal paste on the CPU, it's too deep. Okay, on the CPU, you see that CPU thermal paste, and so that it takes away some bit of heat, but you put in that CPU, this is red grease instead of thermal paste. Never try it at home unless you are desperate, you have nothing you can do about it. Then that fan will be sucking air, but because under the fan there has to be a cooler, an aluminium dissipator, aluminium fin with aluminium fins, which will distribute the heat. It has more surface area. Heat will be distributed in the fins of the cooler, and this fan will be used to take them out, take the heat out. It will suck it out and in the box, and the exhaust fan outside the box, in the back, will pull it out, and then the power supply has its own fan which pulls the power out, the heat out, I mean. And then the front, you can put as many fans as you want on the motherboard, I mean on the case. You can use splitters, whereby you have one fan here, for example, you put a splitter and connect like two fans or even more, but it depends on your needs and how you are going to use it, and also the power of the power supply. You can use this power supply, you get one of the connectors and attach a pin, an adapter, which you can use the fan directly from the power supply. Okay, you will use Google, use everything to search and find out which connectors. So you have to look at it carefully. You have to look at it, and so this thing can be manipulated, can be adjusted, can be upgraded, can be downgraded in many ways, mostly with the USB and PCIe connectors. These ones here are very important. These ones are very important. USB, anything. Look at here. Okay, there is a motherboard, the keyboard, there is a mouse, there is a flash drive, there is hard drive connected. There is so many things. You can connect a phone, two phones. How many phones? You could transfer pictures or videos onto the computer, onto that hard drive here, so that you can watch it on the computer, on TV, and stuff like that. So USB, universal serial bus. That's why it's called universal. The word universal means the earth, the world. Okay, so universal means the whole world. Many things, meaning simply referring to many things you can do with it. Universal serial because it transfers data in series. Okay, and a bus. The word bus does not mean a vehicle, but means many other things. I mean, you can collect many things into one collection. Okay, and this is, you can see, peripheral component expansion express. Peripheral components meaning outside components, just like this one. So this one, I'm not using the graphics card here. Okay, I can take it out, but you have to turn it off. You have to turn it off. Okay, and then you take it out. You can add in another. Okay, some others have many. So there is M.2. So the motherboard, what I have forgotten to tell you is M.2. This one here, there is a motherboard like this one was made in 2013, something like that. So they had not yet integrated. This one was not much mainstream. So this motherboard does not have a slot for this solid state drive. You can see it as small, but this one can be the same weight as this, the same whatever. Like this, it can be the same amount of storage like this one. This one here, it can be the same amount. You can find this hard drive. What is very surprising about hard drives is this one, 150 GB will be this size, and 1 terabyte, which means 4 of them, almost 10 of them, will be the same size. And 100 times will be almost still be the same size. It fits in the same cage, it fits in the same window. They are hard drives, I think of now, is it 30 terabytes or something like that? All very close to that. What I'm very sure about is 20 and maybe 22 something, and 30 something must be there, terabytes, but they're of the same size. So you can find, and in the future, will this go away? I don't know, but this is the future. And if you have the laptop, it has this one, which means it is modern and it is much lighter, because the hard drive is what? The hard drives, mechanical hard drives are heavy. 1, they are slow. 2, 3, they are fragile. They are susceptible to shock. If you hit the computer on the floor or anything, and it shocks, then it will die. So there is very little prospect. There is very little possibility for this to have that shock. Okay, it can also break because it is mounted on a PCB. But because they are labels here. They are labels here and in the back. So I think that one, because they had nowhere to put the labels, but I think that one keeps the heat inside. That is why aeration is very important. You need to get an air supply. Okay, keep it in the cold and stuff and things like that. So let's end the video here. Bye. See, this computer is built from outside. You can zoom it in and see where you can plug what. Oh, I forgot something. Something. Now you will ask yourself, how do you turn it on yet it has no switch? So you have to know these connectors, okay? The hard drive disk and or optical disk drive power. That is one. Okay, there are some two. The switch where the switch is connected. Okay, there are two pins. You're taking me back. There are two pins which you have to identify in the corner. Okay, there are five like this one there. So there are four power switch. You see the power switch PWR switch. It has four parts, four pieces. I mean five standing pins. Okay, so you have to short that one, but you have to connect the two pins using a screwdriver. Okay, using a screwdriver. Because I'm using one hand, you can research on that, but you have to look for the power switch and you should make sure you connect. There are also switches which you can buy from the market, and they will help you to turn it on. What can I do here? Okay, so you will like this one. So you will connect it through here in the corner here. You can search it, by the way. You get a screwdriver. Because the screwdriver is good, it will bridge it. So you connect it here. The two, only two. Be very careful. Don't touch anywhere else. So that is the bridge where you connect these two pins, the first pins for this board, but many others will be different. Okay, there are also extra pins here on other motherboards which are not present here. Okay, so they will be here. They are called front panel connector. So you'll have to identify that whatever you zoom in the pins, and it will be marked power pins. They have no polarity because it is a short. You just connect the two pins. Okay, like this one, you connect it with a screwdriver. Like this is plastic, it does not do anything. But if it is a screwdriver, it will turn this off. If I connect again, then it will turn on. That is it. This one does not have a front power connector. I mean the front panel. They're called the front panel mostly, and I think you have seen it. It's not clear, but you are able at least to see it. So there they are. But they are very small because I'm using the phone, so it is zooming them out. So everything here can be very small. Okay, the front panel connector will be like this. I think this one does or something. You can research also. And there will be a diagram. If you zoom in, there will be a diagram telling you hard drive LED, front panel LED, and stuff like this. HDD LED, where you connect them. I think this one has it. The switch connector. There will also be a what somewhere. Internal speaker connector. I think this is the white one. But this front panel something, I think this is not a front panel, but something like that. So, like SATA connector. So if you zoom in, you will see SATA 0, 1, 2. And so there has to be a SATA 0. That is SATA 0. This is 2 and 1. So this one has 3. So it has 0, 1, and 2. And the third one is broken. So you can add on USB ports for the front and stuff like that. So that's why it is called a motherboard. Everything will be connected here. You have, this is for audio. Many things you can connect. So these are provisions for extra connections. Extras. So these are where you bolt the board onto the case. Okay, onto the case. You have to be careful, like that one which is marked with an arrow. Okay, they are most of the times, is it 6 or 8, something like that. They are somehow standard, depending also on the board, on the size of the board. The board will have a size. They have sizes: micro ATX, ATX, mini ATX, and full ATX, or EATX, extended ATX. This is mini ATX, which is just big enough. And you'll find sometimes you'll find two M.2s. You'll find a board which has 2, 3, 4 of these, or even 5 of these long ones, 5, depending on 5 M.2s and 4 of these. This one you can add another whatever drive here, another card here, okay, another into the PCIe, and you add 4 of these ones, big ones. But I'm showing you to show you how small it can be, and yet doing the same work or even much better work. So this is what on this you can add many things. So the graphics card is running because it is connected, but it's not connected on the screen, but is connected. It's sucking power from the motherboard. Okay, it is sucking power from the motherboard, so it is powered by the motherboard. It does not have extra power for its own on its own. Okay, you can take it out. You can, like I showed you. This one is a push down to release, and it will push it upwards if you push it down. RAM, the same thing. This one is open. The one which has RAM in it is closed. You push it down on both sides, marking the clips. This one is down because it released, so it pushed it up. When you push it down, it pushes the clip up, the card up, or RAM or anything. Most of them, there will be different designs. Some of them are pushed down, some of them are put, but RAM most of the time, 99.9% is pushed down, push upside downwards. Okay, and when you are putting it in, then you have to open them and then press it with 2 hands, because I'm using only 1 hand. Okay, this is NVIDIA Quadro P1000 graphics card. NVIDIA Quadro P1000. It is a big good graphics card, and it uses mini DP. That is the bad thing with it. It uses mini DP, so you need to get a connector, and it can connect 4 screens. So you have to get an adapter which converts, because many of the displays, many of the cables, many of the displays, they are HDMI and DP. full size, but this is mini. There is also micro, but this is mini. So it can connect 4 screens, 4 displays. So that is the NVIDIA graphics card. Even if it is here, it doesn't matter. Like this one, I'm not connecting the screen on that. You see the screen is directed from direct from the motherboard. So this will be the back of the computer here. Okay, these connections mostly they are in the back of the computer. The back of the computer. So you can take a clear picture here and study it in your free time. You can follow that map to connect any computer that they bring to you. It's like when you learn to drive a car. Okay, you need much less, if at all. You need much less to learn to drive a semi-trailer or trailer or tractor or something, whatever, however they call it. Okay, just know the map. The power supply is simple. It can take you like 5 minutes to build. Remember, how many do? They do the same thing in the factory. They do the same thing. These components, they just join them, and go, to push on the line and stuff like that. So this one is a complete one. Okay, no one understands what you are there with your computer, full-fledged. These cables you can buy. Okay, you buy adapters. These cables, SATA cables, power cable. There is power cable, and then there is the data cable for SATA drive. And these ones, IDE to power cable to power to SATA power, IDE to fan power, IDE. So many adapters you can buy. There's micro HD, micro DP to DP to micro DP, DP or display port to HDMI, HDMI to USB-C, to USB-C. So there are many adapters or cables. They can be direct HDMI to USB-C, USB-C or DP to HDMI, full size. Okay, so there are many ways. Those words, there's no, I think, a course better than this one. I wish I had it. I did not. I had to find everything out on my own. I had to find out everything on my own. So by using this picture alone, this can show you. You can do everything by using this video when it is on your table, and once you do it twice, it will become faster, and then you become an expert. If you have some more time in the future, then it can be even your job and stuff. So everything you can build it from here, building programs and stuff like that. Bye. So the power goes in from there inside and comes into the laptop through this side. It is a converter because this is 120 on that side, 120 or 220 something volts. So it will convert it into maybe 5 volts, 2 volts, 1.5 like RAM and stuff, 1.5 volts, 12 volts for CPU and stuff like that. So this is the converter or the inverter, which steps down the power from direct current to it enters a direct current and comes out as from alternating current to direct current, which these common things can use. Okay, that is it. Bye.